Hello everyone, Mr. Cruze here with a video for you, this time the 5.3 Part 2 notes. So hopefully the sub has passed out these notes for you, and basically you're just going to watch this video where I fill them out for you, alright? Hopefully you pick things up as we go. I promise you, if you understood yesterday, this should make sense, alright? So far, we now know 3 ways, and these are on the board. You now know 3 ways to prove triangles congruent. We started with side, side, side. Then we went on to say if we have 2 sides and the angle between them, side, angle, side, that works. And then yesterday we said if we have 2 angles and the side between them, just a recap of what that looks like, if we have 2 angles and the side between them, right, then it is angle, side, angle. Okay? The question is, what happens if we don't have the side between them? What happens if for some reason we have just 2 angles and a random side, not between them? Will it still work? And the answer is yes. And that's called the angle-angle-side theorem. You'll notice this one is the first theorem that we've come across. All the others have been postulates. This one's a theorem. And it says, if 2 angles and one side in one triangle are congruent to their corresponding angles and side in another triangle, then the 2 triangles are, of course, congruent. So I give you a picture here. Triangle ABC is congruent to triangle DEF because it has 2 sets of angles that are the same and just a random side. And make sure that it is the same correct side. Notice the 1 mark is across from the 2 angle marks. The 1 mark's across from the 2 angle marks. Wouldn't work if the mark was over here. Okay? Just make sure that things line up. Alright? And you'll notice that this is angle, angle, side, or side, angle, angle, but more often than not we call it angle, angle, side. Alright? The real question is, why does this work the way it does? Okay, why is this the case? Why does angle, angle, side work when we said the other one, the bad word, didn't work? And the answer is thusly. Let's pretend I know these 2 angles. Let's say this one's 40 and this one's 50, just for the sake of argument. Then that means this one's 40 and this one's 50 as well, right? But in this first triangle, if this one's 40 and this one's 50, you can take 180 minus those 2, and you end up with this angle up here being 90. But guess what happens in the other triangle? This angle's also 90, right? Which means this third angle is congruent in both triangles, right? And then technically, don't you have angle, side, angle, if that's the case? Now, this isn't complete mathematical proof because obviously I just gave you one set of numbers. But here's the kicker. It works no matter what numbers we put in any of these slots, right? For instance, you could go 10 degrees, 20 degrees. That's 30. That means this would have to be 150. Well, guess what? If this is 10 and 20, because they have to be the same, this is also 150. Every time it'll work, all right? And you'll always end up with angle, side, angle, which we showed yesterday worked. So realistically, angle, angle, side, our new one here, is just a glorified version of angle, side, angle. Alright? That's all it is. It's just a special case. Okay? But that's why it's a theorem. We have to prove it. Alright? So, all we're doing is looking for, do we have any of those ways to prove triangles congruent? Side, 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 angle, side. And those 2 involve, do we have at least 2 sets of sides congruent? The others involve, do we have 2 sets of angles congruent and 1 side congruent? Okay? And they have to be in the correct order. So, are the 2 triangles congruent? If so, state what postulate you'd use to prove them congruent. So, in this particular triangle, I notice that I have a side and I have an angle in both. Okay? So not really much yet, except, remember, anytime you have the bow tie, we have special angle pair, right? So we actually have 2 pairs of angles that are congruent. So it's either going to be angle, angle, side, or angle, side, angle. The question is the side between the 2 angles? If it is, it'll be angle, side, angle. If it's not, then it's angle, angle, side. Well, in order to be in between, it would have to be right there, and it's not, so that means it is angle, angle, side. So yes, they are congruent by angle, angle, side. Simple enough, hopefully. Are these 2 triangles congruent? If so, state what postulate you use to prove them congruent. Well, I see that I have two right angles here. Those are congruent always. I see I have two sets of angles here congruent. So once again, we have two pairs of angles congruent. So it's either going to be angle side angle or angle angle side. But where's my side? Hopefully by now you recognize anytime two triangles share a side like this, it must be reflexive property, right? So we do at least have a side, so that's good. Question is this angle side angle or angle angle side? Well, think about your two angles. If it were angle side angle, the side would have to be here, and it's not. It has to be between them. So it's angle angle side once again. Not surprising, because that's what section we're in, right? Alright, are the two triangles congruent? If so, state what postulate you'd use to prove them congruent. Well, let's take a look at what we have. I see one pair of angles congruent. I see two pairs of angles congruent. And I see three pairs of angles congruent. Well, let's run through our list. Do I have any three angled ways to prove triangles congruent? The answer is no. I at least need one set of sides somewhere. Do I even have that? No, I don't. So I cannot say these triangles are congruent. These are not congruent. Okay? And in case you don't believe me, I'm going to show you a little trick. Let's pretend I do have some right triangle, just like we had, right? And these two angles are the same, right? I can actually copy and paste this and blow this triangle up. And you will see, hopefully it'll do it here for me. Ah, there it is. The triangle is the same angles, right? If I were to superimpose, these two angles are the same, and these two angles are the same. But notice the side lengths are different, okay? So just having three angles doesn't do it. You have to at least have a side to lock it into place. Alright, are the two triangles congruent? If so, state what postulate you would use to prove them congruent. I see that I have two sets of sides congruent, so I'm tempted to think it's either side, 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 or side, angle, side. I see that we also have an angle mark, so I'm tempted to think, well, it can't be side, side, side. It must be side, angle, side. But look carefully. In this triangle, isn't the angle between the two sides, side, angle, side? But in this triangle, it's not. It's not between the two sides. It's not in the same corner. So are the two triangles actually congruent? The answer is no. They're not marked well enough, right? This is not congruent. This angle right here would have to be here in order for this to work, right? And it's not. So be careful. Make sure you're looking out for that. This can be a little tricky. Are the two triangles congruent? If so, same question. I see that I have one pair of sides. That's good. I see I have one pair of angles. Where's a second set of sides or a second pair of angles? Well, it's a bow tie. Once again, you've got a pair of angles. And then you'll notice angle, side, angle. The side is between those two angles. So this is angle, side, angle. Okay? Hopefully this is making sense. Example 6 says, what other piece of information would you need to prove the triangle is congruent by angle, angle, side? Well, I see I have two angles, right? I've got these two here, and I've got these two here. What other piece of information would I need? Well, obviously I need a side. But if I'm going to use angle, angle, side, it cannot be this side or this side, right? So basically pick a pair of sides other than those two, right? I'm going to pick ZY. We would need ZY to be congruent to, well, what would it match up with? It's across from the 2, so what's across from the 2? That would be segment NM, right? Or, instead of that segment, you could do the other segment. ZX would have to be congruent to whatever's across from the 3, right? Which in this case would be NL. If we had either of those, we would be able to use angle, angle, side. Okay? Hopefully this makes sense. The big deal is that we need to recognize side, 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 right? Side, angle, side, the angle between the two sides. Angle, side, angle. And angle, angle, side. Okay, make sure you know the difference between all of those. You will have a review tomorrow. because we're going to have a quiz on Friday. So you're going to need to know these pieces of information, all right? For now, your assignment is page 254. You notice it's on the same page as yesterday, so you can just add to it. Numbers 15, 17 through 23, 25, and 35. All right? This is what you're going to be working on for the rest of the period. All right? Make sure that you're good for the sub. Don't do anything you're not supposed to do. Stay in your seats. Just make sure you get this done, all right? I expect everyone to have their assignments done and ready to turn in when I return, all right? Good luck, and if you need anything, please let me know. I will still be here probably after school and before first period tomorrow, all right? Good luck and have a great day. I will see you later.